All right, let's look at this problem called counting bits. Given an integer n, return an array answer of length n plus 1 such that for each I, answer of I is the number of ones in the binary representation of I. Okay, so when 2 is given, we have to find the number of ones in all numbers starting from 0 till 2. So 0 has these many ones, 1 has a single one, 2 is 1 0, so it has 1 1, and so on. So for 5, we get from 0 to 5, and for each number from 0 to 5, we count the number of ones in each of them and return that as the array. Now, obviously, to solve for it, one of the ways would be that we go through each and every number, right? And then we find out the number of ones in its binary representation by just going through each and every bit and checking whether it's 1 or 0, right? And that is an easy thing to do. But that means that we do that for each and every number. Could it be slightly more optimal where we can say, hey, the number of ones in 5 depends upon number of, like, based on what we have calculated so far, can we get to the number of ones in that based on what we already calculated? So what I mean is, let's come to whiteboard. So essentially what really happens, right? So if you're looking at 0 and 1, first let's write 0 and 1. So 0 and 1 is easy, right? But after 0 and 1, now when you come to 2, okay, so 2 is essentially starting from 2 onwards. What's really happening with starting from 2 onwards is I have a 1 and now 1 0 and everything repeats, right? So it's 1 and 0 1, right? You just added a 1 and everything else just repeated, right? And now what you're doing is just you're adding, and then you can just call it 0 0. Now what's happening is after this, you're just adding another 1, right? And all four of these will just repeat. So 0 0 1 0 1 1 1 0 1 1 1. And when all ones are done, then you add another one. And now what will happen is all of this will repeat, right? So you'll have 0 0 0, and then all ones is 1, and all of these will just repeat again. So can we use that fact, which is essentially what it's coming down to is, hey, ones of x is always equals to um, one extra one plus ones of some y, right? And we can find out that y somehow. That's the main thing, right? So for example, for this is what, 7. So ones of 7. So this is just repeating this, which is 3, is equals to 1 plus ones of 3, right? And similarly, when you are at 1 1 1 1, what's really happening is ones of 15 is equals to 1 plus ones of 7, right? So essentially, it's all changing at every power of 2, right? So from one power of 2 to another power of 2, like between, so for example, ones of 8 will be just be one, a single one. Every power of 2 just have a single one. And after that, like, what is ones of 9? Ones of 9 equals to uh, 1 plus ones of 1, right? And this will happen till for 10, it will be one digit and ones of 2, right? Because one digit we're getting from 8, so 8 essentially till 16, right? So this is 8, and we know 8 has a single one, and then 9, 10, 11, 12, 13, 14, 15, and 16 again will have another one. But everything in between, you can just write this as 8 plus 1, 8 plus 2, 8 plus 3, 8 plus 4, right? Every power of 2, and all of these have already been calculated. So if I know the last power of 2, right? So what I can say is ones of x equals to 1 plus ones in x minus last power of 2, right? And this example, this last power of 2 was 8. That is for all the cases, or ones of x equals to 1 if it is a power of 2, right? And if not, then it's just this. And we can just continuously keep building using this capability. So let's come to the code and see how that would look like. So what we're saying is let's first define a ones array equals to new int and plus one, and will at least be zero. So that means and the array size is n plus one. So we can always just set ones of zero to zero. That's fine. Let's also try and set ones of 1 to 1 equals, but this we can only do if n is equal to 1, but or less than equal to 1. So if n equals to 0, for that case we'll just return once here itself. Otherwise you can also set this, and let's use this called something called last power of 2, and we'll set it to 1, right? So 2 to the power 0 is 1. And now for everything else, so for 2 till n, there's two cases, right? One, if I itself is a power of 2, and how do we check that? So whatever was the last power of 2, if you multiply it by 2, you'll get another next power of 2. So if I is the next power of 2, then what you can do is well, then once of I equals to just 1, and we can also set this last power of 2 to this guy, right? And if that's not the case, then like we came to the conclusion, it would be just 1 will get added, and we can just do ones of I minus last power of 2, right? Those many ones would be there. And so that is it, right? And at the end, we'll return ones. All right, let's run this. It gets accepted. Let's submit. And it is submitted. It's accepted as well. All right.